Good morning, children. Myself, Rabindra Kumar Jena. So I will teach you the DC generator. Students, it is a very interesting chapter in our electrical machine. Now, as you know, who plays well is called as the player. Good. Similarly, who sings well, you tell me, what is that? Who sings well is called as the singer. Similarly, who swims well is called as the swimmer. Good. So exactly in a similar fashion, I can say who generates well is called as the generator. So therefore, we understand the generator meaning. So now question arises, what does it generate? So obviously we can say it generates the electricity. As you know, according to our conservation of energy, energy neither can be created nor be destroyed, but it transfers from one form to another form. Now question arises, since we are getting the electricity, but how does it come? Where does it come? So therefore the answer is, it comes from the mechanical energy. Now I can explain you very clearly and interestingly, a machine which converts mechanical energy into electrical energy is called as the generator. So this is the very beautiful definition of our generator. Before that, we have the DC, direct current. So therefore, whenever the output electrical energy we get in the form of direct in a DC form, then it is called as the DC generator. Therefore, lastly I can say the definition is, it is defined as an electrical machine which converts mechanical energy into electrical energy in a DC form is known as DC generator. So now, this is the definition of DC generator. Similarly, you just check this block diagram. Interestingly, you can see now at the input side we are providing the mechanical energy. At the same time, output, what you are getting? Electrical energy. Therefore, the machine which converts mechanical energy into electrical energy, that is called as the DC generator. Now, again, now the explanation says, or our we can say as the question arises, in which part actually this type of things are happening, how it is happening, where it is happening. These are the different types of questions in front of us. Now I am going to teach you and show you the different parts of the DC generator and how it is now converting into electrical energy. Now I am going to show you the beautiful model. Now you just see, I am just showing you the beautiful model now. This is one electric machine. Now you can see this is one electric machine. This portion is called as the yoke. This portion is called as the yoke. You can see in your textbook also. Now I am just opening a beautiful thing. You just see, I am opening this one. What is this? So this is called as the internal parts of the DC generator. Now before showing and before make you understand this the internal parts, now I am just going to show you. Just you see, this is the internal parts of the internal things connected or installed inside this yoke. Now upper portion is called as the yoke, and inside here you just see this is called the magnetic pole. Everybody, do you understand it? Now you see these are called as the magnetic poles. One, and this is two, North Pole, South Pole. As you know, single pole does not exist in this universe. Therefore, we have two separate poles. One is North Pole, this is South Pole. Two pole machine. So now these poles are now mounted and connected at the inner side of the yoke. So this is very interesting and beautiful. We can see very easily, you can see the inner part of this yoke, and this is one magnetic pole, this is another magnetic pole. Now, I am just showing, this is called as the armature. The armature is now inserted inside this. Now just you see, in the magnetic pole and the armature, we have a very small gap, millimeter gap. Now I am just taking it out for your reference. Now I am showing this portion, exactly what I am just rounding my finger here. This portion is called as the armature. This portion only, armature. This armature has slots and teeth. Again you see, this type of projected portion is called as the slot, and this green color you just see, I am just opening it. Here we see this is groove-like structure is now found this is called as the slot. This portion is called as the slot, and the projected portion is called as this teeth. Now, whenever you are going for the winding, copper wires are inserted through the slots, not through the teeth. Remember it. In the two conjugate or adjacent teeth, we have this slot. Inside this slot, we are providing the our copper conductors. Now, this is the armature winding, and this is called as our armature core. The core has slot and a teeth. Again, you see these copper wires you might have seen very easily. You can see here these copper wires taken through the slots of the armature core, and these are called as the armature windings. As you know, armature windings of two types. One is called as the lap winding, another is called as the wave winding. So I will just detect it very clearly, what is the lap and what is the wave, what is its figure, everything. But now you just see another parts. Here another parts is your commutator. Just you see, I am showing you this part is called as the commutator, which is also mounted over the same shaft. This is called as the commutator. It has number of segments as the number of armature coils. As many as the number of segments as the number of armature coils. How many coils you are forming? Exactly same commutator segments you must have. So this is mounted over the, this is shaft. This is called as the commutator. The main function of the commutator is to convert alternating current into direct current. So that you understood very clearly. Now you can imagine, you can see also how the armature core is designed, how the armature windings are inserted or embedded. Similarly, where is the commutator and how does it look like? Everything you can get it. And similarly, we have another, the ball bearing. Now just you see, I am holding this ball bearing and I am rotating. You see very freely it is rotating. Very interesting one. So now if I keep inside this machine, now you just see, now it is rotating like this. This is rotating. Now you can imagine and you can realize how this armature is now rotating. So now this is the different parts of the your DC generator. I explained you very clearly. Now again you just come to the explanation. How this DC generator works, function of a DC generator. Now you just see, this is one magnetic pole, this is another magnetic pole. Whenever these magnetic flux are coming from north pole to south pole continuously, uniform magnetic field. At the same time, we are just using any prime mover, we are rotating this armature. We are rotating. Now we can say this armature coils itself is rotating under the influence of a magnetic field. So what does it then what happens? So according to Faraday's laws of electromagnetic induction, certain EMF will be induced in this armature coil, So therefore this induced EMF is alternating in nature. Now this whatever EMF is induced here, that comes to our commutator segment. That I have already make you understand. So this is called the commutator segment. So whenever we just make a closed circuit, the current will flow. So therefore this commutator segment converts alternating current into direct current. That direct current now available for the taking of electricity from commutator segment to outside for our external use. So this is the basic fundamental of our DC generator. Thank you. So this is the explanation or working of a DC generator.